This time on the laboratory, we're not going to be working on Lemax. As a matter of fact, I'm not going to fix anything. I'm going to tear apart a dollar bill collector from a soda machine. The soda machine's from the 70s, and this dollar bill collector is tested on December 11th, 1996. Anyway, the soda machine is no longer a soda machine, and this wasn't working correctly, and I think it's because the belts are going out, because this belt has more tension than this belt. This belt's really sloppy, and this belt's a little tighter. So I think the machine is wedging because when we had power to it originally, the bills kept getting pulled in sideways. So I'm going to use it for parts, and I need this faceplate here for a project. I don't need the machine itself. But the faceplate's held on with one screw and a nut. There's the nut, and here's the screw, which is caught on the plastic. And then it just slides up and off. There's a couple little fingers here. And I need this faceplate and these two feed ramps for a different project. So this is just going to be scavenged. But for those who've never seen the inside of a bill collector from a vending machine, this is it. So this would normally sit like this. You put your money in. If it accepts your dollar bill and doesn't spit it out at you 30 times, the bill is then put in here. It's fed up inside, and this is what holds it. And it's kind of interesting because I didn't realize this. The bills go here, but they use a foam sponge material as the shock absorber to keep tension for the stack of bills. So I thought it used a small spring setup, not a memory foam sponge. So I learned something when I looked at this. It has an optical reader here, in here, which is why the picture on the front shows you to put your thing in face up and don't have any folded corners, because the optical reader is on the edge. So there's one on the top, and there's one on the bottom, and then there's one back here. So, and I think what it's doing is it's reading to see if it's a dollar bill and not a 20 or a 5, and if it's face up, face down, so on and so forth. So, but looking at this, it looks like there's going to be some usable parts that might be usable in other projects, because it does have a large tooth stepped gear. We have a large tooth gear, which some things like Department 56 and Mr. Christmas especially use. Lemax not so much. We got some pulley guides, and even though these belts are stretched for this machine, the belts are still very pliable and they're not cracked. I did inspect it when I pulled it out of the machine yesterday, and these are tooth belts, which it has teeth on the back side of the belt for feeding around the gear. And then there's another set of belts back here, which are smooth belts. And they're big. And a lot of belts and a lot of the stuff, the big belts are hard to find. So, there's a through bolt right here, which has 2 blade or 5/16 head screws. Let's see if I can get them to break free. That's one. I've never seen the inside of a bill collecting machine from a vending machine, so this will be a first for me as well. So there's the housing that holds the dollar bills. Here's the shaft that the threads into. It's a double threaded shaft, which might come in handy for stuff. Like I said, I like to scavenge parts for future projects. This is the power plug. This plugged into the coin part of the machine, and then it had a bypass that went to a basic control board for the buttons. So this is a bypass plug. It's got the pins that goes through, and then it just taps off whatever pins it needs to use, which there's 8 pins, but there's only 3 wires that come in. Here's your power transformer. It has a part number but no rating on it. So I'm assuming it's pulling in close to 120 volts based on the size of these pins, this cord, and the fact the machine's a 120 volt machine, and it's probably putting out here the low voltage step down is probably between 5 and 24 volts. It's also probably DC, not AC. The transformer is held on with a 5/16, and it's not a screw type, so you have to use an actual socket to get the transformer off. They use a buttload of zip ties, as you can see there. I'm going to undo the zip ties. And then the unit itself is a Row International model CBA-2, in case anybody cares. So, and I'm assuming this was put in 96, 97 when it was tested, because the machine does not have a smooth cutout. It's a hack job where this fed through, then they have a big plastic bezel covering their hack into the machine. So I think the machine was just a coin machine, and then it was retrofitted to take dollar. So we're going to plug the different connectors. So there's the transformer connector. And then these go to probably the motors in here, because there's two motors. And I'm curious if the motors have any markings on them, such as power. We got screw style and standard 5/16 nuts, or bolts. So let me see if I have a 5/16 handy. Messed up kit here. Yeah, some of these aren't marked. Cheap Chinese. Yeah, that one says 5/16, but it's missing from the sockets. Alright, so I might have to go find one. Alright, what's we got here? And I didn't mean 5/16, it's a 1/4 inch. My bad. I don't know why I said 5/16. Perfect. Now let's get this out of the way. So let's take this side off and see if we can see how this thing works. Get a general idea, and then see what kind of parts in here that might be reusable. I'm sure this thing would work if it had new belts, and probably could resell it, but I need parts of it for a project. Like I said, that's what I do. I scavenge parts, especially when it comes to stuff that I don't want to pay for brand new, and it's recycling. So this one right here just held an idler pulley, which is right there. That's what the belt ran in. So if you have a product that has an idler pulley, like some of the front yards do that have the motion, it would have a slightly bigger version, but there's an idler pulley from Lemax as an example. transformer off. It has one screw, then it slides out of a lip, and of course we got another zip tie. You can never have too many zip ties. Now, normally I keep transformers. I can look it up and see what the outputs are, but I probably am just going to recycle this, send it to a recycler. We would send recycling stuff usually every few months, motors, transformers, wires, just because of its age. And transformers are relatively inexpensive. Things have gone down a lot when it comes to certain electronic components. And honestly, I have too many of them just lying around. So. Alright, so it looks like I got all the screws off of this side. Got a couple of small screws in the back. We got some indicators for power, status, and then there's a reset button that says test. This one has some nuts on the inside. There we go. Nuts, washers, and spacers. And that's because this is acting as a heat sink, probably for some voltage regulators that are down in here. I got the one side unscrewed, but it doesn't want to separate. So I'm going to unscrew the other side. And of course, if you collect random nuts, bolts, screws, you got some fine thread and coarse thread hardware, self-locking and non-self-locking, standard and Phillips. So that just removed that motor. That motor just fell with those, with that screw and that screw there. I'll do it without my hand. Those two. Here is the motor and the motor spacer plate. This motor has markings on it, so let's feed the wires through and see what the markings are. This is a 12-volt AC motor. It's a Coleman motor. That's interesting. It was made in Wisconsin. Wisconsin or Wyoming. The second letter is cut off. So this is 12 volts AC, not DC. And it has a red and black input on the bottom and a yellow input on the top, which I think is kind of interesting. It has a part number. I'll probably look it up and see why it uses 4 wires. Some of the carousels, and especially some Department 56, like the ski slopes and stuff, and the rotating buildings, and the Mr. Christmas, they use a lot of AC motors. So if this is a good motor, it might be usable. It already comes with a brass or bronze gear pressed on. Not a big fan of those when it comes to certain things, because this gear, being nylon, is designed to be the sacrificial gear, because this won't. This gear is probably a little bit easier to replace and access, so that's why they do it that way. Here is the plate that mounts the gear. So there's your pin that the gear slides on, like so. The gear looks pretty decent. I don't see any cracks, fractures. This gear is held on with what we refer to as a Jesus clip. It's kind of a nickname because when it flies off and it disappears into outer space, you usually yell Jesus or some other profanity. But it's a C-clip or a C-clamp or a spring clip. It seems like everybody calls them something slightly different. It's got 2 little pinholes in it, so you can use the removal tool. You can use a screwdriver and remove it that way too. You just got to be careful because they like to shoot off, and they always have a tendency either shooting in the wrong direction or hitting you square in the face. So if you do decide to remove something like that, just be careful. I've been hit enough times to tell you it's not pleasant. Now, this one here is going into the set of idlers. I'm trying to hold the idlers from spinning. There we go. So these are the idlers I was talking about. It's got a through shaft that's threaded on both ends. We have a nylon bushing on the outside, and then we have 2 more C spring clamps on the inside to keep the bushings spaced apart so they don't compress in too far. So they're just using those to keep your spacing for these belts. This one is the other idler pulley, matches the one that's over there. I've noticed they use oval slots to tension, which is kind of nice. Or if they use a different size belt, they can adjust it accordingly by sliding this back and forth in the slot. This has got a notch on the back that fits in the slot, so it takes care of any of the issues they may encounter. Of course, now this is the next motor. Unplug that and cut off the next zip tie. So here's the other motor. And this belt is caught on the wires. There we go. This motor also has 2 inputs, top and bottom. It's a larger motor that has an eccentric on it, so it just does a small arc. I'm going to see if I can show you that, if I can see how to get this metal plate out. But it moves a mechanism in here. It is also by Coleman. It's a motor, and this one's 12 volts DC. It also has a part number on it, and it is Wisconsin. This one's not scratched off. It says these were made in Darlington, Wisconsin, USA. So it's kind of nice to find something that's made in America. There's a good chance these 2 motors still work. I just need the diagram so I don't put the wrong info on the wrong wires and smoke them, because that would be bad. But I'll take this one out. This is a synchronous motor, it looks like, based on the offset. This has the armature coming out of the center. And this one, the armature is coming out sideways. It grabs that white piece of plastic, and you can see there's a slight groove, so it swings like this back and forth inside this white housing. So we'll take that apart further and explore. We have a nice nylon guide here, which was on the top, probably for the bill when it slides over. Since this is the clip that holds this box shut right here, this clips so. And let's get some more of this out. So the side plates, once you unscrew them, they use notched fingers to hold them in place. I'm going to knock out some more of these bushings and idlers. This idler is held on with another spring clip. So if you have a project that needs a herky piece of metal, it's a herky piece of metal. Here are the belts, which may be usable in other things because they're still nice and strong. So you have 2 smooth belts and then 2 teeth belts. Now, like vacuum cleaners use teeth belts as well. They're usually a lot thicker. I'll give you an example. This is a tooth belt from a Dirt Devil. I don't have the Dirt Devil anymore, but the belt's still good. The belt, it was a spare, and Being a tooth belt, it works with tooth pulleys of the same size teeth. You never know when you find one. And with all the animated stuff I take apart, you'd be surprised. So I'm going to stick these 4 belts and this tooth belt back into my belt holder. That's another idler. Another piece of heavy metal. So here is the lips. So they fit together like so. And then the belt goes around that idler and that idler up across these big idler pulleys as well. And then the bottom had an idler here and an idler here, which then wrapped around and went around this guy here. So your money comes in and is grabbed by this center wheel and is shot up, and then you got this rubber wheel right here that's on a spring for tension. So it's shot up inside. You have your optical reader here, like I was telling you, there's the little hole, and your optical reader here on the other side, there's your little hole, and then this circuit board in the back has another optical reader right in there, and it also has another component which I do not recognize, and then you got 2 LEDs, and I'm not sure what those are for, so we'll see if we can figure it out when we take more of this apart. Rid of that idler. This appears to be clipped in. Yeah, this is just clipped in. It's an interesting way of doing it. So to keep tension on the clip, they folded up a piece of zip tie and wedged it in there. So they acted like a wedge on the top of a hammer or an axe, so the handle doesn't separate from the head. So that's ingenious. It's a way to conserve. May not be factory, it may have been done by a repair technician, but hey, if it works, it works. And this has been in the machine for 26 years, so it's been working just fine. Alright, so there's 2 wire holders right there, and now it's pulled out, and that's where the other optical is. So we have, I can't even tell. This is an optical 132 model, and the other one doesn't have a name. It's dirty as all get out, though. It just has some numbers I'd have to cross-reference. And then we got 2 LEDs. What I'm assuming, and I could be wrong, is that these lights illuminate enough of the bill, and this picks up to see if the bill is counterfeit or not, meaning if it's not a facsimile or if it's a real bill. And it probably also picks up the info on what denomination, because of course every bill looks slightly different. And this optical is really dirty as well. Wow, I'm surprised this thing worked at all with the amount of dirt. And then the circuit board that controls it all is right here. So let's take out this optical sensor, and this unplugs, and that plugs into that board over there. And let's see what it takes to get this other board out, which also has an optical on the bottom. So we have a lot of stuff in here to stop you from faking out the machine. I'm trying to unscrew the axle that holds in. So it's got a nut on the outside with threads on the inside for alignment, and then this pin is pushed through and holds that. So I'm just trying to, there we go, get them out. So I can get a better view at this board and see how this board, and then the board has a reader right here. These kind of readers they use on, similar to what a tape deck uses as an example. On the tape deck, 8-track, so on. That's what would read the magnetic tape, and it's very similar, slightly different, but it's very similar. And that's probably what reads the dollar, and it checks the integrity of the bill to see if it's a legitimate bill or not. Because on new bills, it has the counterfeiting strip in them where it says $1, $1, $10, $100. So this has to know the difference between an old bill and a new bill. So it's probably reading the type of paper it's on. I'm not quite sure exactly what it's looking for. I'm only making assumptions. On this wasn't going to last too much longer, and this one might have been replaced because it's blue. But these are the guides that hold it in place and allow it to spin, and they're pre-split to slide over, but this one is also cracked on the top. So eventually this would have broke off, and then the belt wouldn't have sat square, and it would have bound itself up. So this machine was not too far from failure. Now, how do we get this out to take a look at the circuit board? I think it's just glued in. There's no screws. Or it's pressed in. Interesting. Well, I can't get it out, but using the magnifying specs here, the 8-pin chip is an LM358, so that can be looked up. The rest of the components are resistors. We got a handful of resistors, a couple of capacitors, and we got a transistor, and that's it on the top of the board that I can see. I might have to cut this housing to get the circuit board out in one piece so I can see if there's anything on the bottom of the board. Looking through the holes with the magnifying glasses, I don't see anything soldered to the bottom, but I can't see the whole board. So I might play with that some more later. Then, down here, we have the main board with all the important information on how it works. So, here's the other side. And to get this idler or drive, because this is the tooth side that drives it from this gear, you'd have to pull this spring clip. And then on this circuit board, the processor, I'm going to clean off everything so I can read it all. It's a lot of dust. Processor is made in Japan, and it's a 8M3, and then the chip number is HD like heavy duty, 637, B like boy, 01, V like Victor, 0, CP like Charlie Papa. So that is the main processor. This 6-pin chip is an L8902H. In case anybody wants to look them up and see what they do. Of course, they're all in different directions. This is another LM358, the 6-chip here. The bigger processors are LM2917M, LM3240, a TL918AB, and then this itty bitty 8-pin chip that's only got 7 pins attached is an I455. So on this, if the voltage regulators, which are right here and right here, are any good, they're salvageable. These are potentiometers right here. This is a 10K and a 5K variable. Those are still salvageable. The 2 relays right here should be salvageable, especially since they're made in Japan. I'm not going to lie, Japanese circuitry is really good. We have another potentiometer 10K right there. This is a 5-volt relay. that has the capability of handling 2 amps, 30 volts DC across its pin, so it's a 5-volt signal. And I have a few of these, but mine aren't Japanese, they're Chinese, so I might take that one just to put it in my stuff. And this is a Japanese relay as well, this big red guy. We got a nice fat resistor in here, which could be used for stuff. The reset button is also Japanese. That's amazing. I might keep that as well. And then we got 2 big red LEDs on the back, which are salvageable. So there's some components on here I'd salvage and use for projects down the road. So this isn't a complete waste as far as the components go. The only thing that holds this in were the 2 screws that held these bars across here to hold the 2 voltage regulators to the plate to act as a heatsink, and this plastic pin right here in the center is the only thing that holds the circuit board in that I can see. Yeah, that's it. It's glued on. So, on the circuit board, we got some good components that I'll probably salvage off of here and find some uses for, or down the road. Like these variable resistors, if you're building a big LED light display and you want to change the intensity, you can use these to go from dim to bright. It's also good for volume knobs, but these don't take knobs. You have to put a little screwdriver in the front of them. A small blade, smaller than this, to turn them. So they got the pros and cons, depends on what you're going to use them for. Now let's take a look at this motor and see what it takes to get it out of its metal cage. I think I'm going to have to take these 2 screws out. But yeah, if you ever cared what the inside of a dollar bill machine from a vending machine, I'm sure they're all similar, whether it be a vending machine or a token machine where it gives you tokens or quarters. You get an idea how it works. So that's a slip plate with some grease on it. Looks like I'm going to have to get this one out to get the motor out. So this is what was sandwiched together with a piece of metal in the middle. So we got a greasy plate and we got 2 flat slip plates that have pins in them, and the pins go into this groove. And now we can get the motor out. And when this eccentric works, it has a micro switch. This is the same type of micro switch they use in all the Lemax houses, some of the Department 56, and Mr. Christmas. So when it moves, there's an arm right here that clicks, and it probably kills the power. So this DC motor only has power. The white and red wire goes up to this micro switch and sends a signal back. So this is just a standard motor that probably reverses polarity as it's being used. So it goes one direction, trips the switch, goes the other direction, trips the switch, goes back and forth. Now, how do we get this arm off of here so we can drop the motor? These 2 holes here are for your screwdriver, so you can change said motor. So there's one there. And there's a screw right back here, which is why this also has a widening in the notch. Now we have to move this arm because it's blocking my other screw. Just take the arm off. How about that? screw. So there's that. Now I'll take the micro switch off. So outside of the components I needed, I got two motors, which I'm assuming are still good since the machine tried to function when it was hooked up. I got a micro switch, some components off the circuit board, some metal bracketry, which I probably won't use. I'll probably just recycle it. Some cheap plastic parts, which again I'll probably just throw those away. Lots of idlers, a couple of belts. Like I said, idlers come in handy. Lots of belts, a couple of gears, which may or may not do me any good. It just depends on the size. I'm curious if this is a straight motor and this is just an offset gearbox. But it uses a really small blade screwdriver on the top. So I'm trying to find one real quick. Oh, finally. 10 screwdrivers later, we got a blade. Because if it does, that means I can use this as an eccentric, or I can use this as a offset motor, or I can use it as a straight drive motor, which increases its possibilities. So we just got two screws in the top. So yeah, it's an eccentric, and I can use it as a straight drive motor by removing these stack of gears right there, or I can keep it as an offset motor. And these are they're all metal gears. Put that back on. I do think it's kind of odd. It only had two screws holding the top on. Most of these, if they're like this, especially if they're a higher torque, will have three. Or two screws that are out. You know, two screws are normally for the mounting plate, but they usually have more than two mounting attachments. So this probably doesn't have a lot of torque. But what I can do is we can see if this one works, since I don't need a wiring diagram like the other one does. We can see if it spins. Fine thread screws, they take forever to go all the way down. There we go. So I'm going to turn on my power supply, and also I can see what the amperage draw on this. Because at 12 volts, you never know, this thing could draw 1 amp or half an amp or 30 amps. That's an exaggeration on the last one. Since I'm not going to be using the connector anymore, I'm going to remove the connector and make myself a couple of bare wires. Also, what I think is unique about these two motors is the bottoms unscrew, which I think is interesting. Most motors today, they're completely sealed, where you have to literally pry or cut them open to get inside. All right. So I don't know if you can see that spinning. I'm assuming you can. So I'm going to put this on, just in case you can't see it spinning. And right now at 12 volts even, it's drawing 1/4 of an amp, 0.24. See what happens if I put a load on it. It raises it to 0.36, so a little over 1/3 of an amp. And this has got a lot of torque. That took me up to 0.4, 0.45. So, not a very fast motor. It's a high torque motor. with this gearbox arrangement. And like I said, you can turn it that way, and I bet you what the micro switch did was when it hit that micro switch, it did this. And reverse polarity. Reverse polarity is drawing 0.2 amps and it's spinning slower. So this will go in my box of motors. Maybe one day it'll come in handy for something. This one I'll look up the schematic to figure out what the two sets of wires are. But AC motors are harder to find. I know right now I'm working on a project that requires an AC motor. As a matter of fact, if I get it done, it'll probably be up before this video is. But it needs an AC motor that is no longer made and no longer available. So I'm going to either put the wrong motor in it and see if I can get it to work, or put, when I mean the wrong motor, I don't mean like the wrong motor, but it's going to be the wrong voltage. It's going to be a higher voltage, and see if I can get it to work at a similar speed. Since the manufacturer who made this motor for Limax has discontinued the manufacturing, and nobody else made it because it's considered an oddball voltage for that project. Most AC motors are 12 volt and 6 volt when it comes to hobby motors, and this is a 9 volt, and nobody has a 9 volt AC motor. I've checked with the Chinese companies and I've checked with the American companies. Some things just aren't available anymore. So let's plastic housing. This gear, or excuse me, this feeder is a Bakelite material. It's not rubber, but it's a hard material like Bakelite. So if you need something that is non-marring for the most part, or longevity, this wheel here would work perfectly. Again, I don't just fix things, I also make custom things and pieces like this. Some people say it's hoarding. I call it scavenging, because when I need it, I have it. I don't have to go locate it. That's how I can fix a lot of my own stuff without buying parts. But I do have to buy parts occasionally, since they only can fix things so many times before you run out of parts. If you use springs, it's got itty bitty little springs like this one here. I'm not going to keep because it's rusty as all get out. But if you need a little tensioning spring, you got one in here. It was two. I don't know where the other one disappeared to. The other one right here. This one's not rusty, so I'll probably keep this one and put it in my miscellaneous spring stuff. This one though is nothing but rust, and I don't need a tetanus spring inside my projects. Also, when springs rust and they pit, it changes the spring's resistance and also increases its ability to break. So, right. Wasn't the most exciting video, but you now see the dismantling of a dollar bill machine from an old Pepsi machine. Like I said, the Pepsi machine predates the bill reader serial number and date code by almost 2 decades. So I'm assuming it was a retrofit, since they really hacked up the machine to install this. They have this big plastic bezel and a really jagged hole that's supposed to be a square, and it's kind of a parallelogram. They did a horrible job, but it works. That's all that matters. So anyway, until the next one, whether it be a repair or customization or a dismantling of something, so you can see the insides. Thanks for watching. Hopefully you weren't bored, and enjoy the rest of your day. Till the next one.